would be, you've heard about open source software, what about open source hardware? And this became an interest to me because of my long-standing interest in the study of fish behavior, in particular for wild or free-ranging fishes. And I thought I'd put up an old, kind of like a throwback picture here, back from quite a few years ago now. It seems like yesterday to me, but in reality it was decades ago, studying the behavior of fish in streams. And you can see sort of the technology that I used back then was actually quite advanced, but it was very cumbersome and was rather limited in the technology that we used. And many of you know that a lot of the electronic equipment has become miniaturized, and I've sort of kept track of that a lot with the things like the adventure cameras, like the GoPro cameras that can be made waterproof, used underwater, and have really good ways of collecting video. And I've often thought about that would be a really good system to be able to do studies of fish behavior in the natural environment. And then I've often thought about ways of doing it at a very systematic sampling. So we'd have representative sampling throughout the day and night. And that still is limited, kind of like the way I had it set up here, where someone had to be present to sort of turn things on and off and adjust them in a lot of ways, even though we had better cameras that were smaller and cheaper. And there had to be better ways of doing that. And sort of with the development of what people refer to as the Internet of Things, wireless communication, or even wired communication, they've really become rather advanced and very cheap to use, to have microcontrollers to collect, to control devices like cameras, but many other things too, to do research. And that was sort of brought home to me when I was thinking about this and how to do it. There's a paper published in 2016 in Science, which means, of course, now it must be important because it's published in Science. But it was a small, short article that talked about the use of some of the small microcomputers or microcontrollers that biologists, are using in many different ways to collect data, and that it's very cheap and can be replicated over a much bigger scale. In the case back here, I was limited to the one expensive video camera that I had, but with cheaper and cheaper electronics and the advent of these cheaper computers, people have been able to build a lot of these devices on their own and use them at a much bigger scale and control them with computer programming that they can use on the operating systems. And so this article talked about the ways people have built their own environmental monitoring systems with these new microcontrollers. Everything from controlling crop systems to measure things, automated watering of crop systems, again, where you could control it by computer program rather than having someone to manually turn things on and off. Weather stations, even GPS collars, altimeters for balloons that you could make and set up. And these all sort of could be fed back through signals that can collect the data remotely if it's set up correctly. So this is something that I was really interested in using it for studies of fish behavior, to have very systematic sampling where you didn't have to have someone there all the time, but you could collect representative samples over long periods of time. And that's really stemmed from the development of these super inexpensive computers that I want to tell you about, because that's basically what I want to tell you about, are these computers like the Raspberry Pi, which is basically, now you can get the Raspberry Pi 4 for about $35, and these are full 32 or 64-bit microcomputers, and they have complete operating systems that can run on them. Linux, for example, or even Windows operating systems can be run on these $35 computers. And they have peripherals that really make connection to lots of devices quite easy. They have Wi-Fi, Bluetooth, an Ethernet port, HDMI output, USB, and they're all DC powered. So they're low power consumption that can run on batteries, and are ideal for deployment into field situations where you may not have a direct power supply available. And what's really cool about them is that they can run computer languages, open source languages like Python, but also Java, C programs, anything that you might need to do something at a regular interval, which you can write some computer code to control that for you. And then in addition to this, one of the things that I learned actually was I helped a few engineering students some years ago do a senior project, and they asked me what kind of device I needed in my lab that I might not normally have available to them, and I pulled out some of the expensive pieces that I often have to purchase, and one of them was a current meter. I asked them, well, can you build me a current velocity meter for stream measurements? And they thought about it and came up with a small little input device, which is a little paddle wheel that you could calibrate and estimate current velocity. I think it cost them, that peripheral input device was like $5. So it was super cheap. And then they attached it and controlled and data logged the current velocity measurements with one of these little microcomputers. And that sort of revealed to me that there were lots of different peripheral devices like this: temperature, humidity, light, many of these other things that you can buy over the internet for $5 to $10, which normally, if you wanted to purchase a complete pH meter, may cost you hundreds or even thousands of dollars, and you'd be limited to just one of them. These kinds of microcomputers offer the opportunity to sort of deploy environmental measurements at a much broader scale, and they record the data that they're experiencing or input through standard SD cards, very cheap data record cards that you can retrieve and switch out. So it's a really good system to be able to record data from lots of different places. And these are just some of the examples of these kinds of input devices that you can buy from eBay or something like that. And then there are other microcomputers like the Arduino, which is an even cheaper one. This is what's referred to as a microcontroller or an electronic switch. It's not a full computer, but it has the ability to execute computer code that you can program into the microcircuits. And it can be controlled by things like the Raspberry Pi computer as well. So it offers that opportunity to use those electronic switch to sort of remove the person and make routine on-off procedures very easy to accomplish if you can get it up and running. If you're interested in learning more about those, you can go to this company called Adafruit, which is a nonprofit company that sells a lot of these components. And so I've been displaying a lot of this with some of my students. We've built an underwater camera system that can regularly control video collected over a systematic interval over a 24-hour period, and Hope used that for her master's thesis. And Zane used it is using it for his project right now. And we connected it, we added some peripheral devices like a night that could infrared light that can allow us to record fish behavior at night. And these are some of the other examples that people have used. They're little inexpensive cameras, stream flow monitoring systems. And so here's just one way of thinking about it, is this use of computer science in the form of programming and design from engineering to help support research in biological sciences. And if you're interested in talking more about the Raspberry Pi, I'd be happy to do so. Just let me know.